In this video, we're going to be looking at polynomial long division and also synthetic division. Before we jump into a couple examples, I just want to go over a little terminology we have here. These directions right here, find the quotient and the remainder if f of x is divided by p of x. Those are going to be our directions for every single example we have here today in this video. And just to refresh, if f of x is divided by p of x, we could write that as a rational expression, or we could write f of x divided by p of x, or we could write f of x divided by p of x. And this is how we want to do it when we are doing our long division. We'll be setting it up like this, like long division that you did back in 3rd grade, and we're going to refresh that and take a look at that again, just so you are familiar with the vocabulary that I will be using. This number underneath the division sign, that is called the dividend. And the number outside is called the divisor. The answer that will go up top when we do our division is called the quotient. Notice in our directions, that's one of the things we're looking for. And we'll have some work underneath here, and the number at the very bottom is going to be our remainder. And let me just add a few lines in here. Before we do our polynomial long division, I just real quick wanted us to look at just an old numeric long division type of problem, because the procedure is actually very similar. If we are going to divide the number 857 by 3, think back to how we did this. We asked ourselves, how many times does 3 go into the number 8? Well, 3 times 2, that's as good as we can get. 3 times 2 is 6. We put that number down below, and then we subtract to get 2. Then we drop down our next digit. So now we ask ourselves, how many times does 3 go into 25? That would be 8. We multiply 8 times 3 to get 24. And then once again, we subtract to get 1. Bring down that last digit. So now we have 17. How many times does 3 go into 17? That would be 5. We multiply down 15 and again subtract. And then we have no more digits to drop down, so there's our remainder, and there's our quotient. The procedure that we're going to use when we do polynomials is actually very similar. Just a few little details change. So here's our first one. Here's our f of x. It's a cubic polynomial, and then our p of x. So the way we're going to set that up, 2x plus 3 is our divisor. It goes outside the division symbol. And 2x cubed plus 7x squared plus 2x plus 9. That's our dividend. Okay, so again, just like in the regular long division, we're going to take a look at this leading term right here. We want to ask ourselves, how many times does that go into 2x cubed? Or maybe an easier way to think about it is, what would I have to multiply 2x by to turn it into 2x cubed? 2x times what gives me 2x cubed? Well, if I multiply 2x by x squared, that would give me the term that I'm looking for. So you do your division, that's step 1, and then we multiply down. Except this time when we multiply, you have to be careful. We are going to have to distribute that x squared. We have to multiply it by both terms in our divisor. So x squared times 2x is 2x cubed. X squared times 3 is a positive 3x squared. And then just like in the standard division, we then subtract. So that means changing our signs. So this becomes a minus, and that becomes a minus. First terms drop out if we did it right. 2x cubed minus 2x cubed is 0. And here we have a 7x squared minus 3x squared. So that's 4x squared. And then we drop down our next term, plus 2x. Okay, then we start over again. We look at our leading term over here on the left, 2x. What would I have to multiply that by to turn it into 4x squared? Well, 2x times 2x gives me 4x squared. And then I multiply down, again remembering to distribute, so I get a 4x squared and also a positive 6x. Next up, I need to subtract, so minus and minus there. First terms drop out, I get 2x minus 6x, so that leaves me with negative 4x plus 9. Now back to the beginning again, what would I multiply 2x by to turn it into that negative 4x? I multiply by negative 2. Multiply down, again distribute, that gives me negative 4x minus 6. I'm going to subtract, so this becomes a positive and that becomes a positive, and our remainder is 9 plus 6, which is 15. So in terms of the way they asked the question, our quotient is x squared plus 2x minus 2, and our remainder is 15. Sometimes you'll see those written as just one long expression. We could write it like this too. 15 over our divisor. That's another way we can write that remainder. Okay, so that one is a pretty basic, straightforward problem. We're going to look at the next one, which has a little trick to it. Here's one of the things that you need to remember when you're working these kind of problems. Put it right up here across the top in red. Okay, we always need to make sure that all powers of x are included in our dividend. Okay, so let's scroll back and look at the first example. Notice here our dividend has an x cubed term, it has an x squared term, it has an x term, and it has a constant. So 3, 2, 1, 0. Now if we look at this next example that we set up and we look at our dividend, notice we have an x cubed but no x squared. We need to put a placeholder in there. Now we can't just add in an x squared term, that would change our polynomial. But we can put in as a placeholder 0x squared, and then we just continue on. There's 9x and our constant of 2. So now we have all the powers, 3, 2, 1, and our constant. Once we remember to do that, this example is going to be a lot like the last one we just did. So again, we'll start off, what do I multiply 5x by to turn it into 25x cubed? I would need to multiply it by a 5x squared. And then I multiply down. Don't forget to distribute. We get 25x cubed. And then we also need to multiply it by that plus 1, so we get another plus 5x squared. We need to subtract, so we change those signs. The 25x cubes cancel each other. 0x squared minus 5x squared leaves me with negative 5x squared. Drop down the next term, the 9x. Now what would I have to multiply 5x by to turn it into negative 5x squared? I would need a minus x. Distribute that x back down again. We get minus 5x squared minus x. We subtract. That becomes a plus and a plus. Change those signs. First terms cancel each other. We get 9x plus x. That's 10x plus 2. What would we multiply 5x by to turn it into 10x? We just need to multiply by 2. Multiply down. And then we need to subtract, so we change those signs. This time when we subtract, oops, sorry, let me get my pen back. Both of our terms go to 0. So this one doesn't have a remainder. The remainder is actually 0. So we just have a quotient this time, and it is 5x squared. minus x plus 2. There's our solution. Okay, there's one more thing that we need to remember, something that can show up in problems like this. And we'll see it in this next example, example 3. And our note here, okay, so we have to remember to always represent all powers of x. The other thing we need to make sure we need to do is line up like terms under your dividend. Okay, and you'll see what I mean here in a minute when we start to work this problem. So let's write this one out. Our divisor, the thing that goes under the division symbol, is 4x cubed minus 2x squared. We don't have an x term, so we need a placeholder in there for 0x minus 3. And we're going to divide that by 2x squared minus 1. Okay, start off the same as before. What would I multiply this leading term by to turn it into this term right here? I would need to multiply 2x squared by 2x, and that gives me 4x cubed. So now I'm going to distribute down. My first term I get is 4x cubed, so I line it up right here under my x cubed term. Next I get a minus 2x, so I don't want to put that right here under my x squared. I want to put it under my x column right there. So if you want to, you could put a 0 in here to keep things lined up. But again, be sure you line up your like terms. Now we're going to subtract. So we change those signs. 4x cubed and negative 4x cubed drop out. Negative 2x squared minus 0, so that doesn't change at all. Sorry, can't get my gray pen back. There we go. Over here we're at 0x plus 2x. And then we drop down our next term. Okay, again, starting same procedure. What would I multiply 2x squared by to get negative 2x squared? Just need to multiply that by negative 1. That gives me negative 2x squared. Negative 1 times negative 1 is plus 1, so I want to line that up here with my other constant. Draw the line and change the sign. That's what one of my teachers used to say when we were subtracting. So we subtract, the first terms drop out, and we are left with 2x minus 4. So our answer, our quotient is 2x minus 1. Our remainder is 2x minus 4. Or if we wanted to, we could write that all in one expression. The remainder divided by our divisor. Okay, let's do one more example with this long division. This is a pretty basic one because it is going to set us up for the next type of problem that we're going to look at. So we have 2x squared minus 3x plus 1 divided by x minus 2. What would I multiply x by to turn it into 2x squared? I would need to multiply that by 2x, then multiply down. We get 2x squared minus 4x. Draw the line and change the sign. When I do that, now I get x plus 1. What would I multiply x by to turn it into x? That almost sounds like a trick question. It'd just be multiplied by 1. Then distribute that 1 down. I get x minus 2. Draw the line and change the sign. That's my new phrase for subtraction. Then our remainder is 3. So our answer this time, the quotient, is 2x plus 1, and our remainder is 3. Again, we could write that 2x plus 1 plus 3 over x minus 2. Okay, now this one was a pretty basic problem, and when we have our divisor that looks like this, meaning that it is a linear term, and again with a coefficient of 1 on your x, then we can use a shortcut division technique called synthetic division. So that's what we're going to look at next. We can't use synthetic division for everything. That's why we also look at polynomial division. But if you're dividing by a linear term that has a x coefficient of 1, we can use this synthetic division technique. So we're going to do that same problem we just did, but we're going to do it using synthetic division. And I made some little bullet points over here to the side. The first thing you need to do is write the coefficients of your dividend in a row, and you still have to remember to represent all powers of x. Okay, so coefficients of our dividend right here. I'm just going to write the numbers, not the variables. My first coefficient is a 2, and then a -3, and then a 1. And then next up, I want to take my divisor, set it equal to 0, and solve. So if I took x minus 2, set it equal to 0, that would be x equals 2. Put the result in a box in front of your row of coefficients, just like that. I usually just put it in a little bracket box, whatever you like. Then we're ready to do the math. What we do first is just drop that first coefficient straight down. You just copy it down below the line. Then you multiply. You multiply whatever's under your line times whatever's in the box. So in this case, 2 times 2. And you write that in your next open column. And then you add. -3 plus 4 is 1. And then you multiply again. 1 times 2 is 2. And then you add, and that's 3. We're done. So now, how do we interpret this answer? These numbers below our line are the coefficients. And it's always going to be a polynomial that's 1 degree lower than what you started with. So since up here we started with an x squared term, this is going to be my x term, this is going to be my constant, and this is going to be my remainder. So the way I would write that would be 2x plus 1, that's my quotient, and my remainder is 3, which is the same result we got when we did this using long division. So let's try a few more of those. Once you understand synthetic division, it goes pretty quickly, but it takes a few times. Okay, so first off, we're going to write out the coefficients of our divisor. So we have 2x cubed, -5x squared, 3x, and 7. Notice all our powers of x are in there, 3, 2, 1, 0, so that's good. And then we take this divisor, set it equal to 0, and we solve. That gives us x equals 2. That goes in the little box. We draw our line, drop down that first number, just copy it straight down. Then you multiply. 2 times the number in the box, 2 is 4. Then you add. -5 plus 4 is -1. Then you multiply. -1 times 2. Then you add. 3 plus a -2. Oops, sorry, that's a positive 1. Then you multiply. 1 times 2. And then you add, we get 9. Again, these are coefficients, and our result is going to be 1 lower degree than what we started with. So we started with an x cubed, so that means our answer is 2x squared minus x plus 1. That's our constant. That was our quotient there. And our remainder is 9. Again, like I did in the long division examples, you could write this as one expression. You'd put the 9 over the divisor. And one more synthetic division. Okay, again, start off by writing out your coefficients. We have an x to the 4th. Doesn't have a coefficient, so that's 1. 1x to the 4th. There's no x cubed term, so we need a 0 in there as a placeholder. So there's our x to the 4th. There's our x cubed. X squared is -14, x is 15, and our constant is -16. This time in the box, if we set this divisor equal to 0 and solve, we get -3. Draw your line, drop down that first number, and then we just do a series of multiplications and adding to get our result. So 1 times -3 is -3. Add them up. Then multiply. -3 times -3 is +9. Add them up. -5 times -3 is +15. Add those two. 30 times -3 is -90. Add those two. Those coefficients give us our answer. Since our original polynomial was an x to the 4th, This leading coefficient down here is going to be our x cubed term. So we have 1x cubed minus 3x squared minus 5x plus 30. That's our quotient. And our remainder is negative 106.